Hello, my dear students. Once again, welcome back to our online education platform for the integrated classes, the VAVA classes. तो ये पार्ट रे हमें क्लास 12 ର रिलेशन डिस्कशन करबे स्टूडेंट्स. This is introduction. Now, what is Cartesian product of sets? Let A and B, okay, let A and B be two non-empty sets. The set of all order pair AP such that A belongs to A and B belongs to B. Okay. So since it is A into B, so in order pair AP, the first component A must be belongs to A, and the second component B must be belongs to B. Is called Cartesian product of set A with set B and is denoted by A into B. Okay. This is called Cartesian product of sets. For example, let A equal to 1, 2, 3, B equal to AB. Then A into B, according to the definition, A into B is order pair set of all order pair AB such that A belongs to A and B belongs to B. Then it will be 1A, 1B, 2A, 2B, 3A, 3B. These are the all possible collection of order pair of A into B. Okay. Now, question. I'll solve one question. One MCQ. What is the Cartesian product of A, which is equal to 1, 2, and B equal to B? So here Cartesian product of A into B equal to, it will be 1A, 1B, 2A, 2B. Okay. 1A, 1B, 2A, 2B. Since A cross B equal to a possible order pair AB such that A belongs to A, B belongs to B. So according to this, A into B is 1A, 1B, 2A, 2B. So 1A, 1B, 2A, 2B. Yes. 1A, 1B, 2A, BB. This is not the right option. 1A, 1B, 2A, 2B. Yes. Second one is the right option. 1, 1 cannot be the element. This D is not also the Cartesian product. So B is the required right option, students. Okay. Okay. He also mentioned here, if A and B are two non-empty sets, then the Cartesian product A to B is a set of all order pair AB such that A belongs to A and B belongs to B. So given A equal to 1, 2 and B equal to B, hence A into B equal to 1A, 1B, 2A, 2B. Now, what is relation? This is Cartesian product. In previous case, we have discussed Cartesian product. Now, what is relation? Let A and B be two sets. Then a relation R from set A to set B is a subset of A into B. Is a subset of Cartesian product A into B. Suppose A is a set and B is a set. Then A into B is the Cartesian product of A and B. Any subset of A into B is a relation. Okay. So R is a relation from A to B, that implies, that double implies R is a subset of A cross B, or any subset of A cross B is a relation from A to B. If AB belongs to R, we say that A is related to B under the relation R. We write it as A R B. That is A is related to B by the relation R. Okay. If A and B are finite sets consisting of M and N element respectively, then the total number of relation from A to B is, since the total number of element in A into B is Mn, and total number of all subset of A into B is power set of A into B equal to 2 to the power Mn, that is same as the total number of relation from A to B, which is 2 to the power Mn. Okay, because all subsets are power sets, are elements of power set of A to B. All subset of A into B is element of power set of A into B, but all subset of A into B is relation. That means we have 2 to the power Mn relation from A to B if A contain M element and B contain N element. Okay. Now, suppose A contain 4 element, B contain 3 element. Then the number of relation from A to B is 2 to the power 4 into 3. That is 2 to the power 12, which is equal to 2 into 2, 4 into 2, 8 into 2, 16 into 2, 32, 64, 128, 256, 512, 1024, 2048, 4096. Okay, that is from A to B, you can have 4096 relation. Okay, so here we'll understand the relation by another way. One second, yes. Friends, this is suppose A set and this is suppose B set. Suppose A set contain 1, 2, 3 and B set contain 2, 3, 4. Okay. Now, what is A into B? What is Cartesian product of AB? Cartesian product of AB is 1, 2, 1, 3, 1, 4. What is again 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4. This is the Cartesian product of A and B. Now, any subset of A into B is a relation. Suppose R equal to order pair xy such that x less than y, then R is a relation. So what is the element of R? Now it is 2, 3, it is 3, 4. Okay. Because first component is smaller, second component is larger. So it is 2, 3 and 3, 4. Now, by this relation R, 2 is related to 3. 2 is related with 3. So you can represent by arrow diagram. 3 represented with 4. Okay, now you see. This is a set A, this is a set B. Here, two element of A, 2 and 3, related with two element of B, 3 and 4. That is 2 is related with 3, 3 is related with 4. By this relation R1. We can set another relation. Suppose we can take R2 equal to order pair xy such that x equal to y. Then R2 is a subset of A into B. So what is the element of R2? So element of R2 is again 2, 2, 3, 3 because x and y are equal. Now you can see we can make another relation between A and B. Okay, here this is A, this is B. Element of A is 1, 2, 3. Element of B is 2, 3, 4. Okay, since the relation R2 say that 2 is related with 2, 2 is related with 2. And 3 is related with 3. Okay. So we say that element of A is related with element of B by this relation R2. So relation means a few element of A or every element of A is related with few element of B, some element of B or every element of B. Then it is called a relation. Sometime sometime every element of A is related with every element of B. Sometimes no element of A is related with no element of B. Okay, we have special definition for that, but this is a relation. If few element of a set, if some element of a set is related with some element of another set, then it is called a relation. Relation ମାନେ ତ ସେଇଆ ନା କିଛି ସମ୍ପର୍କ ତିଆରି ଥିବ କିଏ କାହା ସହ ରିଲେଟ ହଉଥିବ କୌଣସି ନା କୌଣସି ଦ୍ୱାରା ଯଦି ଗୋଟେ ଫ୍ୟାମିଲି ଗୋଟେ ସେଟ୍ ହେଲା ଆଉ ଗୋଟେ ଫ୍ୟାମିଲି ଗୋଟେ ସେଟ୍ ହେଲା ଏ ଫ୍ୟାମିଲିର ଜଣେ ଗୋଟେ ମେମ୍ବର ଆଉ ଗୋଟେ ଫ୍ୟାମିଲିର ଜଣେ ମେମ୍ବରର ଅଙ୍କଲ ହୁଏ ତା ମାନେ ମୁଁ କଣ କହିଲି this is a set. So suppose X is a member of this set and this is another set. Y is member of this set. Suppose X is uncle of Y. ଯଦି ଆଉ କିଛି ଆଉ କିଏ କାହାର ଅଙ୍କଲ ହଉଥିବେ ତାହେଲେ ରିଲେଟ ହେଇଯିବେ ଯଦି ଆଉ କିଏ କାହାର ଅଙ୍କଲ ନୁହନ୍ତି ତାହେଲେ ଏଇ ସେଟର ଗୋଟିଏ ଏଲିମେଣ୍ଟ x ସେଇ ସେଟର ଗୋଟିଏ ଏଲିମେଣ୍ଟ y ସହିତ ରିଲେଟ ହବ only one element of this set x is related with another element y of this set b then x is related to y that is a relation and relation is presented as this way suppose x is related with y by the relation y X is related with Y by the relation R, we say that order pair XY belongs to R. Okay. Uh, Now, what is domain of a relation? Let R be a relation from set A to set B. Then the set of all first component or coordinate of the order pair belong to R is called the domain of R. The domain of R is A such that AB belongs to R. Clearly, domain of R is subset of A. Okay. So, what is range of relation? We'll solve problem based on this. Let R be relation from set A to B. Then the set of all second component or coordinate of the order pair belong to R is called the range of R. Thus, range of R is B such that AB belongs to R. Clearly, range of R is subset of B. Now, we'll understand with the help of one example. Suppose A equal to 1, 2, 3, 4. B equal to suppose 2, 3, 4, 5. Suppose. Now, what is A into B? A into B contain 16 element 1, 2, 1, 3, 1, 4, 1, 5, 2, 2, 2, 3, 2, 4, 2, 5. Okay. Then 3, 2, 3, 3, 3, 4, 3, 5, 4, 2, 4, 3, 4, 4, 4, 5. Okay. A into B contains 16 element. R is a relation from A into B. So R is a subset of A equals B. Suppose R equal to order pair XY such that again same thing X equal to Y. Suppose X equal to Y or X is greater than Y only. X is less than Y. So R contain element like 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. Okay. So R is this relation. Now, a domain of R, dom R, sometimes it is as dr, is a set of all fast components. What is the fast component? 1, 1, 1, 2, 2, 3, 4. So, domain of R is 1, 2, 3, 4. Set of all fast component, which is a clearly a subset of A. This time it is equal to A. So, domain of A is purely a subset of A or equal to A. What is the range of R? Written as Rng of R equal to set of all second component. What is the second component? 2, 3, 4, 5. Okay. This time range equal to B. But range is always subset of B. Okay. It may be a proper subset, it may be improper subset. Domain and range are always subset of A and B. Here domain is improper subset of A. Here range is improper subset of B. Okay. So this is all about domain and range. Now, next class we'll discuss relation on a set. Okay, students. So till then, have a nice day. Bye, bye, students. Thank you all.